Okay, Assalamualaikum and good morning. Okay, can somebody respond to me whether you can hear me or not?
Yes, doctor.
Okay, good. Morning. So today is only a short topic. Okay, it's called data interpolation. So this is a very useful tools when you want to do some project and data analysis. So what is data interpolation? So for example here, if you recall back, you learn in your school about the linear equation y equals to mx plus c. Okay, so you have this, and then for example you have a quadratic equation x squared plus x, okay, ax plus bx plus c equals to 0. So this is a equation. Okay, so I choose this one. For example, y equals to 2x plus 1, for example. So from this, you can collect the data from the equation. So from this, okay, for example, if I want 1, 2, 3, 4. So what is 1, 2, 3, 4? X. Okay, 1, 2, 3, 4. Y is, so 1, 2, 3, 3. This one is 5. This one is 7. This one is 4, 8, 9, right? Okay. So you know the equation, you know this. Okay. But the problem is, usually when you do experiment, you have this data. Okay, you have the data, but you don't know the equation. Okay, so you don't know this. So to do this, not to get the equation, but try to get the point, okay, other point. Okay, you do interpolation. Okay, from this data, you can plot something like this. Okay, so around something like this, x, y. But the problem is when you want to, if you have the data and you want to revert back, and you don't know which point. Okay, so you have point, something like this, right? So you want to create this data back. Okay, that is interpolation. Basically, it is connecting between data. Okay, that is interpolation. So today we will learn the 1D interpolation data using a inter P1 function inside the MATLAB. Okay, and write the MATLAB code to find the unknown between some value. So you have some data. Okay, if you have some data and you want to find the data in between the value you already obtained, you can use interpolation. Okay, write the MATLAB code to plot the interpolated data and understand the use in engineering. So this one is a very useful tools. Okay. So we start with the, okay, this one already explained, interpolation data. Interpolation. What is interpolation? Is basically a mathematical process that estimate unknown value between known point. You have a known point, you want to estimate the unknown value. Okay. For example, MATLAB function connect data point by drawing a straight line between 2 points. So this one is a linear example, a straight line. Okay, interpolation between 2 points. So you have known point here and here. Okay, if you want to find the value here, okay, this one is unknown, so you just do a linear line, and you can get this value. So this is very useful tool. So interpolation is basically compute missing value between 2 points. Okay, so this one, interpolation original point are preserved. So basically for interpolation, all the point we set the point we known, the line will cross all these points, right? So for example, you have 3 data. Okay, for example, you have 3 data here. Okay, if you do interpolation, okay, all the value will be preserved. Okay, will be preserved. So, but curve fitting is not like this. Okay, this is the difference between interpolation and curve fitting. Okay, so basically curve fitting is basically converting. Okay, like I showed before, it's actually a curve fitting, not interpolation. Interpolation is basically try to get the line to that point. But curve fitting is basically, for example, you have data, you have data here. So curve fitting is basically try to get the estimate equation. Okay, so this is a linear equation, y equals to mx plus c. So from this, basically, based from this data, you try to get the best linear mathematical equation for this data. Okay, so curve fitting does not need to the original data point to be in graph. So this is what it means. It doesn't need to meet the original point. Okay, as long as it is very close. Okay, so that is curve fitting. This is interpolation. So this is the two different. So make sure you know the different. Okay, and for this class, we focus on the interpolation. Okay. So how to do this code is basically a simple interpolation data. Okay, interpolation function inside the MATLAB. This one. Okay, and this one. Sorry. So this one, the code. So make sure you know the code. It's inter p1 or 1. Okay, inter p1. Okay, so this is for only one dimension. Okay, for this case, this one is a sample. Okay, for example, you collect data, you have x and v. So you have 1, 2, 3, 4, 5. Okay, you test a manipulated data is 1, 2, 3, 4, 5. Then you get the result is around 3, 5, 7, 9, 10, for example. Okay, so this is the output data. So this is x, this is v. Okay, or x or y. Okay, so this is your sample data, the input and the output. Okay, the x or the y. Okay, sample data corresponding value of x. Okay, and then this is the interpolated query point. So basically, you have this point. For example, you want to know what is 2.5. So you don't know 2.5. So you put here. You want to know the point where you want to add additional data. So you put here, interpolation query. So for example, you want 2.5, 3.5, and this one is 4.5. So if you want something like this, you have to use a MATLAB. Okay, remember, if you have multiple point, you have to put in square bracket 2.5, 3.5, 0.5, and 4.5, and then close bracket, square bracket. Okay, so that is how to use it. And the method, okay, there are several methods that available. Okay, so depend on you. You either you want to use. We will discuss this later. Okay, so there are various methods you can use. There are various interpolation method. Depend on your requirement. So this is the interpolation method. Okay, so basically you have a nearest. Okay, nearest neighbor interpolation. Okay, basically for this case you need to have at least 2 points. Okay, I will show you what is the difference later. And then linear, this one is linear interpolation, is basically try to create a straight line between connection between 2 points. Okay, so this one also at least 2 method, 2 points. Okay, so this one, okay, this value x and v, you need to have at least 2 set. Okay, you need to have at least 2 number. And spline, okay, this one is the piecewise cubic spine. Okay, this one usually much more curved. Okay, so this one is linear between 2 points. This one try to create a point. I will show you later. It's much more easy to see when you in the figure. Spline is around is more towards curving. This one is also a little bit like a curve, but it is okay. I will show you later. And both of spline and CP hip, okay, require 4 points at least. Okay, you need 4 points to create this. Okay, open your MATLAB and try to do this coding and make sure you submit the code. Okay, what you have done in the MATLAB, in the e-learning. Okay, just to make sure that you done the work. Okay, so you can see here you have a data here, x. Okay, so you have the output. Okay, basically this is the output. Okay, 0, 1, 1, 0. So you have n1 is basically the point. So basically n1. So you have n1. Oh, okay, n1 and x. Okay, so you have n1 is from 0, 1, 2, 3. Okay, from this. Okay, sorry, not this. This. Okay. Okay, and x is the 0, 1, 1, 0. So you have data something like this. So this is the basically the input, and this is the output. And this one, n2, is basically the point in between. So for this case, you have 0, 0 0.2, 0 0.4, 0 0.6, and something so on until 3. So basically, you want to be more detailed. You don't have the data, but you want to interpolate the value. Okay. So you already got this, and you use the inter p. Okay. So use this code. Here you have n1. Okay, n1 is the original input. X is the original output. This one is the interpolated input. Okay, n2. Okay, and this is the method you want to use: nearest, linear, spline, or PC hip. Okay, and the output will be this one. This is the output of the interpolation. Okay, so let me clear this. Okay, so now you already obtained the data. Okay, so basically you want to plot this data. Okay, n1, x1, 0. So this is the original. And then you want to plot the n2. So n2 is the input of the expected interpolation. Okay, remember this one. And this one is the output of the interpolation. This one. Okay. So you plot this, and this with the different type of tick. Okay. And remember, this one is just a continue. Okay, means that 3 dot means that it's continue to the next line. Okay, if you can use this. Okay, of course, this one is the X label, Y label, title, legend. So legend, you have to follow the plot. Okay, this is the first plot, the first one, the second one, the third one, the fourth one, and the fifth one. So original point, nearest, linear, spline, and PC shape. Okay. So after you plot this, you will get this. So remember the original point here, you get 4. Okay. This one, 1, 2, 3, and 4. This is the original point. So if you look here, the nearest point, okay? If you want to use this, you can see here, okay? You have this data, okay? It will create a straight line, okay? And then you divide by 2. At this point, it will change, okay? So it's something like this. If you want to use the nearest point. So this one is not too popular, okay? Depend on the data, but usually we don't use the nearest. So if you look here, it will create a straight line. And then this one, okay, you can see here, it will also create a straight line, but at this point, it will change. So this is the nearest, okay? If you want to use the nearest, it will produce something like this. Okay, let me clear. Okay, next. Okay, linear. Linear is much more popular actually. So if you want to use linear, it's basically create a straight line, something like this. Create a straight line between 2 points and this one. Okay, so this one is the interpolated data. So this one interpolated, this one, this one, this one, this one, this one, and so on. So straight line is quite popular actually, quite useful. If you want the data to be a linear, okay, linear interpolation. Okay, let me clear that. Okay, next is the spline. Spline is also quite useful. Okay, so spline is basically you have a, if you know the ruler, the what you call the spline, the curve ruler. Okay, you can buy this to create a curve. So if you can see here the purple, okay, so you can see, so this one, okay, you have dark point here. So you can see it is curve. Okay, it's try to curve according to that point. Okay, it will be something like this. Okay, basically it has some curve and try to follow the known point. So that is spline. If you want to use spline method. So this is also quite useful in interpolating data. And also the last one, this one also. So depend on the, okay, depend on your data. So spline is much more, it's something like a combination of spline and linear. Okay, if you can see here, this is the plot. Okay, it's try to curve, and then at this point it just straight. Okay, and then this. So that one, if you want to interpolation using PC heap. Okay, so make sure you know all of these 4 methods. Okay. Okay, in engineering, especially in electrical engineering, interpolation is quite useful. Okay, just to evaluate unknown value between 2 known points, or try to increase the detail of the signal. So very useful interpolation. Okay, so we take a break to, okay, we take a break to take the attendance. So we continue. Okay, we continue with the evaluated unknown value. So previously I show you how to create, okay, a plot. Okay, but if you want to evaluate unknown value, So how to do this? Okay, this is an example. Okay, air pollution index. Okay, I give you an example, air pollution index. So you have this one is the distance. Okay, and this one is the index. So based on this, you have to create okay, this is known data. Okay, this is known data, and known data. And from this, you have to do some interpolation. So use this. Okay, this is, okay, you create a function. Okay, so you can see here a function of API value. This one is the km, the distance. So you have the known data here. This is the distance. This one is the API. Okay, so this one is the distance d. Okay, and this one is the API. Okay, air pollution index. So this one, okay, this one is the interpolated input. Okay, so you want to have an interpolated input. So, and this one is the interpolated output. So use this coding. So this one is the non-input, non-output, interpolated input, and this one is the interpolated output. So from this, okay, so you have y. So where is y? So y is created around API km plus 1 and 0. So for this case is just a location, I think. Okay. So from this you create this one. So where is it? Oh, km. Okay. So km, okay, you round it up. Okay, you can see here you have the input. Let me clear this first. Okay, you have the input km. Okay, so basically you want to round all the value inside the km. Okay, you round it up. Okay, because okay, you want to insert here. Okay, and then you print the result. So API value at what km? Okay, this one you insert it is this one. So basically you round the data. Okay, that's it. This is the function just to round the input. Okay, the interpolated input. So then also you plot it. Okay, try to understand it. This is the just to create a figure. Okay, new figure. Okay, if you want to create a new figure, you use this code figure. And then you use the plot. Okay. So you use the plot, the ticks, format, okay, the label, the title. Okay, this one is the title, the grid. You turn on the grid. Okay, basically if you have a plot, remember, you want to put a grid. Okay, so 0, 1, 2, 3, you have to grid on. And this one is just to add the text. Okay. So this is the result of the function. So after you save the function, you have to save in file, remember? You have to save the file. How to create a function? Remember, you create a file named API value. Okay, make sure the function needs to have the same name. Okay, the file needs to have the same name as the function. Then after you save it, you can use this function. Okay. So if you want to know the API at 10 kilometer, you get the answer. Okay. At 2.5, you get the answer. At various location value, you get the answer. Okay, that is how you create a function to obtain the result. So let us test this. Okay. So I just copy this. You have to create a new script, save it. Okay. And make sure you need to save the file according to the function name, save it, and make sure you don't run this inside your program file. So make sure you click this open, okay, put on desktop or my document. Okay, so save it. Okay, and then to run this, okay, you copy this. Okay, okay, and then paste in the command window. Okay, so there is, you have to change this. Okay, save again. Okay, try again. So automatically you get the value as well as the plot. Okay. Try, if you want to try another value. Okay, it also create this one as well as the plot. Okay, try to understand this. Okay. Okay, I give you another example here. Tree diagram. So I think this one is not very related to you. Okay, because this is much more towards chemical engineering maybe. Okay, so you have X, you have Y. So you don't need to understand the problem too much, but you need to understand how to do the solution. So from the table, determine Y at X equals to this value. So basically, you want to find here, what is the number here? Okay. So how to do this? Okay. So the solution is to create a interpolation. Okay. So you have something like this. I think this one is spline. Okay, look at the curve. I think it is a spline maybe. So let us check the code. Okay. So you have the X value here, you have the Y value. Okay, the X is, so this one is the X. Okay, so 0, 0.1, 0.2 until 1. And the Y is 0, this one is the data. So you just put the X and Y here. Okay, and then you use spline. Okay, so this is the output of the interpolation. Okay, and then you have the input because the question asks you what is 0.45. So you just insert this value, one value only. Okay, so you can either use spline or PC heap. Okay, and you just print. Okay, try to check again how to do printing. Okay, so after you do this, you get the answer. And this one is the for plotting. Okay, for plot, you just plot the value. Okay, so no interpolation for this. Okay, the result here is just interpolation. When you do plotting, it is just a linear interpolation. That's it. Okay, automatically when you do plotting, it is linear interpolation. Okay, so if you have one value to obtain, you just put the value here. Okay, another application. Okay, for electrical engineering, actually, this one, for increasing the detail of the signal. Okay, so for example, here you have the ECG, okay, electrocardiogram. So you have usually this one, ECG, you have a signal, okay, signal, something like this, signal, and you use the analog to digital converter. So basically, it changed the analog signal to digital. So basically, something like this point, this point, this point, this point. Okay, basically, it's create a digital. Okay, it's not continuous. Okay, but when you want to plot it again, okay, it is, you need to smooth it out again. So that is why you use interpolation. So For this case, I cannot do it because I still not receive the load that the herd data. Okay, for this case, I need a data. So you can use this data, okay, to create interpolation based on spline. Okay, this is just a plot. Okay, I think this one you still not not familiar. Okay, let me show you. Okay, you just when you do plot, you just put this equals to something. Okay, plot, when you do plot, you press equals to something. So basically, when you want to change anything, you just do this P1 and dot line width. You can adjust it here. You also can put it here, no problem. Or if you want, this one is another way, just to avoid a very long plot code. Okay. So this is the result, interpolation signal. Okay, original, this is the original data, which is very incomplete. Okay, this one also incomplete. Okay, especially at this point. So after interpolation using spline, okay, you can have this curve. Okay, it is much more clear. That is why we do interpolation. Okay, so this one, digital to analog, is another electrical example. So you have a digital signal, you want to convert to analog. So audio signal like MP3, okay, or your video, anything that you look at your phone, for example, okay, or here at a phone, is basically a digital signal. So basically from this digital signal, it is not continuous. You can see here it is not continuous. So you have to do some interpolation, okay, so to smooth out the signal. So basically it will go something like this. Okay, after interpolation, you use digital from digital to analog. Okay, and you have a low pass filter to create a signal again. Okay, same as here, I don't have the data. Okay, this example requires some data. Okay, the same thing, of course. And for this case, you have multiple method. So method, you have this one, this one, this one, and this one. So basically, you use for to move between method. Okay, I is 1 to 4, and method is just method, this method callback, and change with I. Okay. So interpolation, and this is the method, and the rest is just a plotting. Okay. So just plot. So this is the result. So basically it will interpolated. Okay. Okay. I think that's it because this topic is quite short actually. This is just a simple equation of okay. This. Okay. This one. Okay. Today we just learn about this one. How to use it. Okay. Basically, it's just you have a sample here, input and output, and then you have the interpolated input. Okay, what value you want? Either you can be single or multiple value. Okay, and then this is the output of the interpolation, and of course you have to choose the method. For method, you can use nearest, linear spline, or PC heap. Okay, piecewise cubic Hermite. Okay, but usually the popular one is this one. Okay, linear and spline. And make sure you know that you need to have at least 2 points for this case, okay, and 4 non-point for this case. That's it. That is you learn for today. Okay, and then you can practice. Okay, you can try to practice here. So interpolation drill. Okay, given y equals to this one, where x is 1 until 10. So it is useful to find y when x equals to this one. Okay, the answer is not. Why? Because you already have the equation. Why you know you need to do interpolation? So interpolation is basically when you don't have this. Okay, you don't have the mathematical equation. Okay, you only have the data. Okay, this data and the data. Okay, so basically when you do have the equation, you don't have to do interpolation. You have the equation, you just insert x equals to here inside the equation, you get the answer. So be careful. So given a data pair of this one and this one, okay, and this one, write a MATLAB code using a linear interpolation. So basically, if you can see here, you don't know this one. Okay. Let me clear this first. Okay. So you have 1, 2, 3. So basically, this is a known data, and this is the unknown data. So this is the interpolated value. And you can see here, okay, this value is unknown. Okay. So basically, because MATLAB is you have to create a unknown here, because this is the unknown. So basically, you have to flip the data. Okay. So flip means that instead of, okay, so you have look here. So in, out. Okay. So input is 3. Okay, and 5.1. Okay, output is okay, output is 1 and 1.6. Okay, you have to flip it because the unknown is at this location. Okay, so don't forget to flip this. Okay, and then you need to find the in interpolation is 4.5. And because you only have 2 points, you can use either nearest, okay, nearest or linear. But for this case, it's already mentioned here, you have to use the linear. Okay. So how to do this? So basically, okay, you have a, so for example here, x is equals to square bracket 3 and 5.1. 3, 5.1. So y is, okay, 1 and 1.6. So the unknown interpolation value is, for example here, not m, n. N is 4.5. So just use the code. M is equals to inter P1. Okay, so X, Y. Okay, so don't forget to flip this. X, Y, and N. And method needs to be linear, because the question already told you to do the linear. So basically, M is this value. Automatically, you get this value. Okay, that is how you do the question. Okay, next, you have to repeat question 2 for this number. Okay, what is question 2? So check back. Oh, this one. Okay. So you have a new data, and for this time it is at this location. So this one doesn't need to flip. So let me clear first. So this is the unknown data. Okay. So this is known data. So how to do this? So for X is 4 and 1. Yeah, 4 and 1. Okay. So this one, 4 and 1. And for Y is 1 and 2. Okay. And then you want to get the value here. So N is 3.2. So basically M is INTER P1 X Y N, and the method is linear. Okay. Don't forget the comma. And you also get the answer. Okay, for this one, write the comment for each code. In example, this one I think already many of it already explained. You can write the comment. I think no need to worry on this, but you can try this. Okay, for example, 11.2 using the curve fitting method. So for this one is what? Example. Okay. So for this case, you have to test every interpolation method. Okay, I think for this case only. Okay, I think this is by default the linear. Okay, if not mistaken, the by default is the linear. Okay, so you can try this. The other example here. Okay, you can try to further strengthen your knowledge on interpolation. Okay. I think that's it. For today, we just learned on this simple code, which is called interpolation for one data 1D only. Okay, any question before I end the class? No, eh? So just a info. For this Wednesday, we will not have class. Okay. And next week, we have a mid-sem break, so there will be no class for 1 week. And after Hari Raya, I think it is very close to Hari Raya, so many of you still on the Raya mode. Okay, so for the next week also, okay, the week 10, okay, this is week 8, week 9, okay, this is week 8, week 9 is the mid-sem break, and week 10, I will not do any class. So you can have a 2.5 week breaks for this class. Okay.
Thank you, Doctor.
Okay.
Thank you, Doctor.
Thank you, Doctor.
Okay, welcome. So see you again after 2.5 weeks.
Thank you, Doctor.
All right. Thank you, Doctor.
Okay, welcome.